TM 55-285, War Department Technical Manual, Operation Railroad, General Instruction, Inspection, Maintenance, Mailing, Rolling Stock. Alright, Section 8, Wheel and Axles. Raw steel wheels, rim defects, burnt rim, rule number 32. If portion of flange rim breaks with coarse fracture showing with a rough granular surface that indicate that the wheel was overheated with the course of manufacture, which will withdraw from service. So this is what shows like a burnt rim in figure 34. Figure 35 is a piece of flange tread which broke away from the wheel, shown in figure 34. Figure 36 shows a shattered rim showing smoother parting surfaces. Figure 37 shows a shattered rim showing more than tread broken, showing the tread broken away. Figure 34 and 35 illustrate with a defect. Figure 35 shows the piece of flange and tread which broke away from the wheel of the figure 34. Shattered rim, rule number 33. A portion of the flange rim separated with the remainder of the wheel reveals smooth surface. Any considerable area of the wheel with shattered rim will be removed from surface. Figure 36 shows with a smoothing parting surface at the end of the figure 37, which show with the same defect for the more of the tread broken away. Figure 38 shows with the back of the flange, same wheel with figure 39 shows with a similar defect with large smooth areas. B in middle milder cases shattered structure occurring to the tread of the wheel is illustrated in figure 40 and 41, appearing with somewhat similar deep seated shelling, but it usually can be distinguished by smoother parting surfaces within greater irregularity angles made by the surfaces. 3. Spread rim. Rule number 34. If the rim widens out over the short distance either on the front or back surface illustrated in figure 42 and 43, interior defect indicate that the wheel will be withdrawn from surface. The spring of the rim may or may not be accompanied by shelling or exterior of the tread, usually accompanied by a slight flattening of the tread resembling certain extent of the slid flat spot. The conditions indicated in figure 42. Interior defect is causing spread rim, and it shows figure 42. 38 shows shattered rim, back of the flange. 39 shattered rim, large smooth area. Shattered rim, milder type. Figure 41 shattered rim showing similar deep seated shelling. Figure 42 spreaded rim. Figure 43 spreaded rim. 44 illustrates a uniform curling over the outer edge with the dots spreading. Similar to leading shattered rim, spread rim is identified with the local spreading with the rim usually less than 12 inches in length, but not confused with the uniform curling over the outer edge of the rim of the figure 44, which is the common surface condition not classified with a defect. Subsurface defect, rule number 35, with the turning of the wheel will not appear with the defect with the rim tread. Sometimes it is clothed with laminated flaky condition seal under the surface of the similar shelling similar shattered rim defect. Such wheels will be scraped in figure 45 and 46. Subsurface defect found with the turning of the wheel. Subsurface defects which were uncovered while the wheels were being turned. 5. Shelled tread. Rule number 36. A. If the surface of the tread breaks down, flakes over the spalling of the wheel of the shredded tread. Figure 47, 48, and 49 show the different degree of the shelling on the same wheel. In certain cases, the shelling may be extended completely around the circumference of the tread, may penetrate a considerable depth if the rim shows the tendency to widen out, and describe that under the spreading rim, or if there is evidence for the shattered rim, the defect will be reported as a spread. Figure 46 shows the surface defect found, the turning of the wheel. Figure 47, shelled tread. 48 shelled tread. 49 shelled tread. 50 shelled tread. 51 shelled tread. 52 shelled tread. 53 shelled tread. 54 shell removed 3/8 inch cut. Or the rim or shattered rim not as a shelled tread. If the proper classification defect with doubt with this would true with the case shown in figure 30 shown figure 50, 51, 52, 53, the last appearing on the same wheel of the wheel will be placed within the layout of the spot and spot and cut and taken out of the round nose of the roughening tool. If the defect is not removed with a cut with a more than 3/8 of an inch of the depth at any point with the tread will classify with a deep shell with a scraped up with the figure 50 figure scraped. Figure 55 shows the defect but did not clean up within 3/8 of an inch spot and cut with the defect is therefore classified as deep shelled. If the defect is removed with a cut of 3/8 of an inch or left, there is no evidence of the spread rim or the shattered structure of the wheel may be classed as shelled. It will be turned to remove all the defect with the metals restored tread with the flange contour, then button back and strip with the figure 54 illustrated with the defect which is 3/8 of an inch and spotting cut and cleaned up so that the wheel will be classed as shelled, turned, and reapply the strip of the shell. The wheels will be removed from surface as soon as the defect is discovered. Thermal cracking's rule number 937. Thermal cracks are caused with intensive breaking heat. When they heat with sufficiently high to concentrate with the surface of the tread as a result of the times of the formation of the transverse cracks. These checks occur when the tread of the flange is variable with the right angle for the plane with the wheels figure 56, 57, 58, 59, 60, and 61. Most common type is illustrated in figure 51 where the cracks are confined with the tread of the thread crack. Thermal cracks which are caused by the brake shoe riding over the edge of the rim instead of the center of the tread. Illustrated in figure 57 and figure 58 indicate the brake shoe of the bearing heavily on the flange addition with the wearing all way away with the back of the flange cracks which extend the outside of the tread are illustrated in figure 59. Thermal cracks are serious as they are no means of determining the magnitude of the strains embodied with the wheel structure, and when the development of a thermal crack is highly strained. Show figure 55 show the deep shell removed within 3/8 of an inch spotting cut. Wheel will weaken structure to the point where the wheel may fail. When wheels, thermal cracks will withdraw when the strip of the wheel. The thermal cracks continue to strip of the cracks that develop through the rim into the plate, causing figure and failure in figures 60 and 61. Thermal cracks can be removed by machining, and when removed, the complete with the wheels can be used again. When setting up the wheels to lay with a good practice of the mark of the longest thermal crack with the peak of the crane or front and back of the face of the rim, proceed with the rough cut until the evidence of the crack is removed. The entire tread will be examined to make sure that all the cracks are removed, after which the flange cut will be taken with the wheel blades and service. See abrasions on the treaded surface such as light brake burns or skid burns usually contain a fine network superficially with irregular lines of attack that should not be confused with the true thermal crack checks. The spalling is another tread condition originally classed as a shelling for lack of the established terminology involved with the breakout of the small portions of the track or the treaded metal between the closely spaced thermal crack. The difference between spalling and true shelling is shown in figure 62. 7. Slid flat. Rule number 38. If a slid flat spot will under the freight car of 2.5 inches over in length with the 2 or more adjoining spots on each 2 inches more length, the wheel will be removed and turned. Slid flat spot on the wheel under the passenger car train car exceeds 11 inches in length, the wheel will be removed and turned. This defect is gauged with the wheel defect gauge illustrated in figure 63 and as you've been indicated in figure 64. 8. Build up tread. Rules number 39. With the condition resolved with the black and plastic metal with the tread on the wheel dragged over and built around with the tread and called it heating. In proper braking conditions, skidding of the condition will be aggravated with the continuing with such wheel with the surface as with a regular out round. They will be removed in terms of the restore of roundness as well with the tread and flange contour. Figure 65 show the mid example of the defect caused by heating, while the sliding wheels figure 67 and 67 show the proper shows. Alright, so figures 56 show the thermal tray. Figure 56 thermal cracks. 57 thermal cracks. 58 thermal cracks. 59 thermal cracks. 60 wear failure caused by thermal cracks. And then we're going to read this. Announce example of the figure 68 and 69 show side with the top view south of such defect. The defect may also appear on the cast steel wheels. 9. Flange worn thin. Rule number 40. Flanges at 15/16 of an inch or less thickness will be removed in terms of the restore of the thread and flange contour. This condition is indicated only with the flange takes wheel the defect gauge of the figure 70. 10. Flange worn vertical. Rule number 41. If the flange's vertical surface extends 1 inch, move the more of the tread of the wheel with the removed. Turn to restore the tread and flange contour with a condition indicating the wheel defect gauge figure 71. 11. High flange tread worn hollow. Rule number 42 of the flange is height with a 1.5 inch or more with above the center of the tread with the wheel will be removed. Turn to restore tread and flange contour provisions made with a steel wheel gauge for a determinate flange height. 12. Thin rim. Rule number 43. If the tread is worn with rim thickness, figure 72 is 3/4 inch or less for the wheels on freight cars and 1 inch or less for the wheels on passenger train cars. On the wheels. I showed the big old picture 61 wheel failure caused by thermal crack. And it shows the spalling out of the metal between the fine thermal cracks compared to the true shelling on the bottom. Figure 63 with the wheel defect coupler limit wall journal color, journal fillet gauge, and it shows the method of gauging flat spots, 2 1/2 inches. Then it shows figure 65 a build-up tread. Will be removed with the wheel for the other defect with the rim thickness to reduce the limit starting with the remove the defect, restore the tread flange, contour of the wheels will not be reapplied with the exemption. Wheels 1 inch for the rim thickness of the condemned under this rule may be applied on freight cars. Wheels loose for the out of gauge rule number 44. Wheels showing indications of being loose for the axle, remove the raw steel of the wheels for the out of gauge with the pair with a measure less than 4 feet or 5 3/32 of an inch back with the measured baseline of the paired parallel that exists for the axle. Figure 773. If the pair measured more than 4 foot 17/32 of an inch, throw the measure to the stainless steel wheel with a mounting check gauge. Figure 74. Loose wheels will cause poor machine workmanship. Wheels out of gauge result of the careless mounting press practices. Plate defects rule number 45. 1 radial cracks plate with usually originate either with the hub of the rim with such cracks. Rule report as a cracked hub of the radial cracked in rim considered with the corner with an A6 above covering thermal cracks and cracked hub. 2 careful inspection with defect circumferential plate cracks so the wheel can be removed before. Figure 66 shows a built-up tread. Figure 67 shows built-up tread. Figure 68, built-up tread. Figure 69, built-up tread. There is any danger of failure that may be detected either in the early stage of the length of 2 to 3 inches if the wheels are such crack will continue. The insert of the crack will grow with a cupid bow crack so called with which become the circle of the hub, the circumferential that has end of the out of the word toward with the rims. Figure 75. Still further neglected, the crack eventually will extend out through the rim in the figure 76 resulting with a wheel failure. Figure 70 shows the method of gauging flanges condemnable. Figure 71 shows the method of gauging vertical flanges condemnable. New tread 5/16 of an inch, condemning limited passenger car of the road, engine tender for the freight car, yard engine tenders 1 inch minimum, 3/4 inch minimum, 1 3/8 of an inch, 1/8 of an inch critical line, measuring line, condemning limited wheel steel rods, cast iron one wear wrought with one wear cast steel wheels are made out of gauge left with a 4 foot 5 inch of the measure from the baseline, multiple 2 year wrought multiple wear cast steel wheels less than 4 foot 6, 5, and 3/32 of an inch. Cast iron wheel wrought 1 wear cast iron wheel steel with out of gauge wear with 4 foot 6 and 5/32 of an inch were multiple 2 wear wrought made multiple wear cast steel wheels more than 4 foot 16, 17, and 32 of an inch. Alright, plate cracks originate with the holes burned with the plates. Figures 77 and 78 with any wheel showing evidence of the application for the torch electrical arc are applied with the drum. The truth will not be applied with the application of the torch electrical arc. Any portion of the wheel with the burning of the weld with extremely dangerous will not be done. Hub defect with rule number 46 with the hub failures taken with the form of the radial cracks. Figures 79 and 78. Or 79 and 80. They show the back of the frame from the front of the hub from the same wheel crack shows occurring in the mounting. Alright, your cast iron wheels, slid flat, rule number 47, the slid flat wheel with the down of the wheel when spot is 2.5 inches or over the length with the 2 more adjoining spots, 2 inches over the length. Figure 81, 82 will be removed with the probably discover the slide flat spot with exceeding 1 inch length with the condemnable under passenger trim of the defect gauge. When the wheel, the defect gauge is shown in figure 63 and 64, illustrated 64. B shell out rule number 48 freight car wheel with Deming well when shell out spots figure 2.5 inch or over. Figure 83 shell out spot of the drive the name of the fact with resemble the inverted oyster shell with a high center. Furthermore, one wheel pair with a developed shell out with the other wheel may be unimpaired shell out 1 inch long or over with the condemnable under the passenger train care with the measurement of the length of the spot made in circumference for the navigator of the tread with the high spot with the center is a distinctive feature of the shell out. Figure 83. C. The seams. Rule number 49. One of the most serious defect with the cast iron wheel of the seam and tread with the defect with located close to the flange. Generally causes breaking of the flanges. Sometimes the surface with the metal may cover the entire seam of the flange. Break off with the more before there is any evidence of the seam of the surface. 2. A wheel may be removed any of the seam found with a running length within the limit of 3 3/4 of an inch of the flange gauge. The shown figure 97. The inspector will take special precaution to discover any of the indication of seam. The figure 84 illustrates the seam and the tread. Seam is such that they may develop in different parts of the tread. D. Worn through shell with the rule number 50. Wheels occasionally are found with a flat or low spot where the wheel's never been slid, with the cause of the chill with being too low in these wheels. When the chilled metal of white iron were out through the soft of the gray iron exposed with the flattened out figure 85, the wheels were not removed from service for this. The defect of the tread is not out of round in excess of Alright, this shows your 4 steel wheels only, and show the baseline with the gauge, inside gauge limited, and check gauge distance, and then it show the outside with the flange. Wheel steel mounting wheels are warm with the flange mounted inside gauge limited plus, and then show the baseline gauges in the head of the rails. Baseline gauge is 4 5/8 of an inch. Gauge of wheels, gauge of track, gauge of face gauge, and then show the picture of circumferential crack extending through the rim. Crack originally from hole burned in place. Crack originating from hole burned in plate. Cracked hub. Alright, 3/64 of an inch one of the arc of the 12 inch of the left of the measure for the gauge shown figure 86 of the care will be taken to distinguish the fact with the flattened spot called with the flattening wheels out of round rule number 51 wheels off of the encounter with the low spot with the tread with which through with the chill is not responsible. Wheels that are out of round limited is described in the figures 86 with the width drawn with the strip of the plane with the gauge for the out of round wheel with the gauge for the locally centered with the tread figure 87. F. The flange worn vertical rule number 52 gauging the worn flange given will be given carefully. And then shows the slid flat cast iron gauge cast iron wheel. Attention, as a worn flange below with the condemning limit may be lead to breakage of the flange wheel. The defect gauge U with the shown figure 7 with the measurement of the worn flange shown figure 71 vertical flange. See figure 88 with the example of the vertical flange with the flange condemnable wheel contact with limited point with the gauge and not merely have the flat surface with limited height. Break, burn cracks from rule number 53. Wheels having the defective treads become the transverse crack due to heating and condemning under the following conditions. 1. Break burn checks and cracks consisting of the transverse cracks of the tread result with except for the heating developed in the brake shoe with the chill with the iron and the tread with the cast iron wheel that cannot withstand except for the localized heating checking and with the cracking results. Wheels removed to the extent of the braking burn is over 2 3/4 inch in length with over 1 inch in length extending beyond the point of the B toward point C in figure 89. C. Any length extending above the wind entirely above point C located midway between points B and A in figure 89. In figure 2, conditions B and C above with the B with the determined gauge shown in figure 63 apply when illustrating figure 89. Figure 82 show the double slid flat cast iron wheel. Figure 83 shows a shell out cast iron wheel condemnable. Figure 84 shows seam and tread and cast iron wheel. Alright, 3. Condemning wheels are soon as the line of the track developed wasteful oil left they located is defined above the accompanying figures 91 and 91 show cave of the brake burn wheels will be left in the figure 92 and 93 show the case of whittle condemning under this rule and show the figure 85 worn through chill cast iron wheel. H. Combination tread effects. Defects. Rule number 54. Cast iron wheels are condemnable when they have 3 or more defects but not more than 3 inches apart with extending circumferentially on the tread distance of 12 inches or more measured in gauge. Figure 80 shift the defect with consist of any or all of the following shelled out spot with 1 inch longer over the butt less than the dimensions stipulated with the rule 43. Flat spots exceed. Except lid flat spot with 1 inch length with over butt less than dimensions stipulated with the rule 48. 3. Brake burn wheel where metal falling out with a circumferential length with a 1.5 inch over less than the dimensions stipulated in rule 53. Figure 8094 illustrates the contamination defects. Alright, treaded worn hollow, rule number 55, achieve the gauge of the figure 95 with examining cast iron cast iron one wear cast steel wheels for tread worn hollow. Wheels often condemning which have not been reached limit because of the mistaken impression that that worn tread is dangerous to run is hard on the track. The true limit of wearing hollow with a tread with a height with the flames above the mentioned gauge is based on the fact that it is wasteful to remove the wheel with the tread worn hollow before the gauge limit is actually reached. Typical example of the wheel properly condemned for the tread worn hollow is shown figure 96. Your burst hub with rule number 56 with the defect with the radial crack with the hub will use develop the wheel press the table plate with the wheel usually is cracked in back hub and then with the core leg opening but in single plate wheel cracks occur with the front hub with the figure 97 the cup with the improper method of the mounting and such with excessive pressure proper fit allowance taper on the wheel bore axle wheel seat with a gauging except for the hard hubs which sometimes occur with the wheels improperly enabled at the foundry and proper fitting allowances often as a result of the use of lubricants wrong consistencies such as wheels will be scrapped. K. Cracked or broken flange plate with the bracket. Rule number 57. The inspectors will check carefully for the indication of the cracks of the plate brackets flange, such as the wheels are likely to fail, but generally wheels break from inside outward. And typical example of the crack plate is shown figure 98. The chip flange shown in rule number 58, wheels are condemned with a flange chip with more than 1/2 inch of the length with 1/2 inch in width. A typical example of the wheel condemned with a chip flange is illustrated in figure 99. Indicate the chip and shell will not interfere with the serviceability of the wheel, therefore will not condemn this. And figure 86 shows the gauge warm through the chill out with a round 33-inch wheel. It's particularly true with the chip, the lack of the flange of Z figure 100. Are your broken rim rule number 59 cast iron wheels frequently condemned with the chipping out of the metal with the outside of the edge of the rim and limit of the distance flange brakes slope inward 3 3/4 inch 3.5 inch from the brakes of the vertical and slope outwardly figure 101 102 and 103 illustrate the message gaming broken rims. N. Wheels loose or out of gauge rule number 60. Wheels will remove the strip of the loosened axle with the out of gauge oil work out with the inside of the wheel with an indication of the loose wheel. Wheels will go the out of gauge figure 73. On the one side of the axle is bent the same as the fact of the producing wheel are boarded diagonal. Alright, wheels subject to fire with the rule number 61. Cast iron wheels have been subject to fire. Ordinarily unit unfit for service with the heat may have drawn out with the chill that cause other injuries. The structure care arises however the wearing wheels wear with the fire will not become unduly low heated or not damage a certain amount of the judgment necessary for the path with the fitness of the the cooling of the wheel. Usually is indicated with the degree of the heating, and in order to determine the definite wheels have the damage in several wheels should be broken, should continuously examine, and a competent officer will make such examination. If it's not possible to make the test, none of these wheels will return to service. Figure 87 shows the outer round 3 and 33 inch of the diameter wheel. Figures show the vertical flange cast iron wheel condemnable. The figure 89 method of gauging brake burn with transverse cast iron cracks and cast iron wheels. Figure 90 show the brake burn when the cast iron wheel is condemnable. And then show the brake of the burns cast iron wheel non-condemnable. Shows the brake burns flange cast iron wheel condemnable. 2 and 9/16 of an inch tread, 2 and 13/16 of an inch. Brake burns cast iron wheels condemnable cracks of 2 and 1/2 inch in length. Figure 89 method of gauging brake burn transverse cast iron wheels. Figure 90 brake burn cast iron wheels non condemnable. Figure 97 and burst hub of the cast iron wheel. 98 crack plate cast iron wheel condemnable. 99 chip flange cast iron wheel condemnable. Chip flange cast iron wheel non-condemnable. Figure 101 method of gauging broken rims considered condemnable. Alright, 44. Axles. Rule number 62. Axles were removed from the strip of the following cause for less than limited wear with the prescribed in columns C, D, and E of the table shown in figure 104. When condemning limited in columns 5, F, and H are reached when axles are correct. When axles have semi-journals when fillet. Back of the journals are less than 1/8 inch radius. The axles of 40,000 pound capacity less than 5/16 inch radius of the axle. 3 3/4 inch condemnable broken rim cast iron wheel condemnable. 3 1/2 inch broken rim cast iron wheel condemnable. Or at 60,000 pound capacity less than 3/8 inch radius of the axle, greater capacity and length of the journal exceeding 11/16 inch of the standard length of the journal length with gauge. Figure 105 will be the check and correct length of the journal. 6 when the collar is broken, worn 3/16 of an inch for length of thickness. And big cars may be loaded limited shown as column A of the table except when the stencil loaded limited is reduced and indicated by a star on each side of the car. Section 9 Fusion and Bronze Welding.